Hey, here it's section 3 of chapter 6 on solving systems of equation using the elimination method. Method number 3. So, the goal to write down the objective for today is to solve systems of equations uh, by adding or subtracting to eliminate a variable. So, what is the elimination method? Well, the way I describe it would be it's a method of solving systems of equations where you use properties of addition or subtraction to eliminate a variable. So let's look at this. This is kind of what we're doing here. If you have, you have 645 minus 242. All right, we subtract each digit. Let's just go right to left. 5 minus 2 is, right, the subtraction sign applies to all of those. 5 minus 2 is 3. 4 minus 4, well, that's 0. That cancels out. And 6 minus 2 is 4. So there you go. If you can add or subtract three-digit numbers, you can do the elimination method most of the time. All right. It works best if both equations are in standard form. So that's where you have a number times x plus a number times y equals a number. So that's the form that we're looking for both of those. And here's the basic steps for using the elimination method. And we'll come back to those with each problem. But first, to make sure, well, let's do this. First step would be, First step would be to make sure the equations are lined up so that the x's and y's are lined up with each other. Meaning x is on top of x's, y is on top of y's. Then we're going to either add or subtract the equations so that one of the variables cancels out. Depends what we have to do. If they're both the same, then we have to subtract them. If they're both opposite signs, then we add them together because then they'll cancel each other out. And then solve for the remaining variable. So that step's usually pretty easy to get the first variable. And then it's just like last method. Then we plug back in that solution for either equation to solve for the remaining variable. And we can check our solutions by plugging back in. So let's do an example or two of these. This one right here, we've got, what is the solution of the system to the right? Use elimination. Okay, those are both in standard form. We have ax plus by equals c, ax plus by equals c. Let's do these steps together now. Step 1, make sure that they're lined up. Well, we have the x's, we have the y's, we have the numbers. Check. Step 2, add or subtract the equations so that one of the variables cancels out. So I'm going to take this thing and we'll look. 2 and 6, they're not going to cancel out right away. So let's see if we can see if the x's will cancel out. Aha, or sorry, the y's. This one has a positive 5y, this one has a negative 5y, or minus 5y. So those are opposites, and if you were to add them together, adding opposites together, it cancels them out. So I'm going to add these whole equations together. All right? So kind of like a three-digit addition problem. We're going to do 17 plus negative 9 is going to get us 8. 5 positive plus 5y and negative 5y, these cancel each other out. And then 6x plus 2x, or 2x plus 6x, is 8x. So we added them together, and the y's canceled out, which is great. Now step 3 says solve for the remaining variable. All right, we can solve for x. This is a one-step equation. Divide both sides by x, and we get x is equal to 1. Awesome. That's the 1/2 of our ordered pair. We just got to find the y now. I'm going to erase this so we can see our two equations. We're going to take that 1 and plug it in for either equation. It does not matter which one. I'm going to plug it in for the first one then. So we have now, we solved for that remaining variable. Now we're plugging it in so we can get this. We have 2 times 1 instead of 2 times x plus 5y equals 17. Got to solve for y because we're missing the y variable. So let's do whatever 2 times 1. This is 2 plus 5y equals 17. And remember, the first thing you do is not divide by 5. You have to get rid of the extra number that's added there. So I'm going to subtract this positive 2. Subtract it over here. And we've got, so we're looking here, we just have 5y bringing it down. It's equal to 15. And to finish it off, we divide both sides by 5. And then we have y is going to be equal to 3. There's our y value. We already had our x value. And there's our solution. Step 4, check. Now remember, you really should be checking your solutions. So if we want to make sure we're doing it right, we got to plug them in for the x and the y in both equations and see if the equations are true. So let's look at the first one. 2 times 1 plus 5 times 3. Is that equal to 17? Well, 2 times 1 is 2, plus 5 times 3 is 15. That is equal to 17. We are good to go there. Second one. So this is step 5. Check. I'm going to go over here. Well, we'll just move everything down a little bit. Make some room. Alright, let's finish this one up here. Check the second part. 6 times x, 6 times 1, minus 5 times 3. Is that going to be equal to negative 9? We shall see. 6 times 1 is 6, minus 15 is indeed equal to negative 9, so we are good to go there. That means our solution is correct. We're done. Woohoo! Now, if you get whole number solutions, oftentimes you're probably correct, but checking it is a great thing to do. So let's do one more example now, following those same steps. And yes, I'm going to bring these steps down so we don't forget them. Alright, here we go. This one's going to be slightly different. We do have it in both in standard form. The x's and y's are lined up with each other, so we're going to take this and let's see. So we're done with step 1 then. Adding them together isn't going to cancel anything out this time. So this time we're going to have to subtract them. So we're going to subtract the whole equation. So just like a regular subtraction sign, that means to subtract everything. So 32 minus 48 would be negative 16. 6y minus 6y would be 0, so those are gone. And negative 5x minus 3x would be negative 8x. Okay, we did that just so that those y's would cancel out. Because if you look at them, if you just add them together, we'd have 12y here. We need to cancel them out by subtracting them. Alright, so we did that. Step 3 would be to solve for x. We have negative 8, divide by negative 8 on both sides. X is equal to 2. Sweet. So we have our x value. Let's find our y value now. We'll use a different color for this. Does not matter which one you plug it in for. Plug it in for the first one then, again. So we have negative 5 times 2 instead of x we're using, plus 6y equals 32. Solve for y. Alright, this is negative 10, plus 6y equals 32. Add 10 to both sides. Oh, plus 10, plus 10. To cancel out that minus 10. So we have 6y is equal to 42. And we'll divide both sides by 6. And get y is equal to 7. And I'm guessing that is our solution. You can pause it and check it real quick to see if you did it right. And I'll do the same. So I plugged in 2 for x and 7 for y in both equations. First one, second one here. And it ended up working that this one, they're equal on that one, they're equal on that one. So our solution was correct. We did it right. That does work. Alright. So the ordered pair 2, 7 would be our solution for this problem. So remember, the big key here is lining them up, making sure there's a way that you can eliminate one of the variables. Do that by either adding or subtracting, and you'll get your first variable and then plug in to find your second variable. And that is the basic concept of using the elimination method. So why don't you take a look at this one word problem. It's in your word problem packet, probably. Write the two equations that would work. It says the difference of two numbers is 34. Remember, the difference is subtraction. And their sum is 338, so that would be addition. And we're going to find the numbers eventually. So FYI, if you say the difference of two numbers, we'll just say x minus y is going to be equal to 34. The sum of the numbers, so we'll do x plus y, is going to be equal to 338. And I'd like you to try to solve this system of equations then using elimination. What is x and what is y? And if you'd like to put it in an ordered pair to make it more familiar for yourself, go ahead and do so. But that is what the problem I'm going to leave you with. Alright? So, review that goal, see what you learned, see how comfortable you feel with using the elimination method to solve for variables, and carry on. Have a great one.